Welcome to a new episode of Science in Context. I'm Sabine, and this week, Professor Samir Bhatt joins me to speak about mathematical modeling in epidemiology. Samir, why are mathematical models needed?
The world is incredibly complex, and this is why outside of physics, trying to predict anything to a high degree of accuracy is hard, often impossible. To see this, just think about trying to predict the stock market and changes in the stock market. But why does this work in physics? It's because there's a language of mathematics there that actually corresponds to reality. Is there a similar hope in infectious disease epidemiology? We can make progress on this by thinking of a model as a collection of individuals. I get infected, you get infected. But this makes the mathematics hard, in the sense you can't write out a series of equations.
Your work focuses on infectious disease modeling specifically. What exactly did you look at in your recent papers?
Well, we wanted to write down these equations, so we focused on an area of mathematics called branching theory. It's really simple. If I go out and infect two people, my infection branches into two more. And so what we did was create the most complex branching model that we could, where you could still write out the equations. And we found that the popular models that others use are in fact a special case of our more general mathematical model.
And why is this model so useful?
Well, you only ever see one epidemic. You can't rewind the tape of time and see what would happen again. And even if we could, we know that the world is filled with randomness, and so the epidemic would be different. Now, these equations allow us to begin to unpick this randomness in a way that you simply can't do in reality, and that's the power of having these equations. Using these equations, we rewind the epidemic, start again, and see what happens. And this is really important to policymakers because we can start making progress on answering the question, what could have happened, or what could happen if you make certain decisions.
Thank you so much for your time, Samir.